Hey class, we are here for lesson 6 in module 4, and we're going to continue our work with area. Uh, as we've been talking about a lot, the easiest and most straightforward way to find area is to multiply the length times the width. So, for example, like the left side of a rectangle times the top of a rectangle, multiply those two sides, and you can find the area pretty quickly that way. And since you guys are doing such a good job with the multiplication facts, it makes it even easier. But we've also seen a lot of work with like tiling and some squares to show the area is the space taken up inside of a two-dimensional object. Today we are going to use, so far we've only seen like complete arrays. We've seen diagrams where the entire grid is filled in. Well, today we're going to get a chance to look at some grids that are not entirely filled in. And let's take a look at some of those now and see how we can deal with it when we have an incomplete array or an incomplete grid in this case. All right, so on my screen, you will see our problem set. So again, you've already had a chance to do this, but this is a review. So we're going to go over something that we've already talked about, which is awesome for you if you need a chance to, go back, better understand what we did in class. So what we're doing here, each square represents 1 square centimeter. That's important. I'm going to circle that. Those are my units, and as you know, units are really important all the time, but especially when we're finding area. Square centimeters means we're measuring in 2 dimensions, so each square here represents 1 square centimeter. Draw to find the number of rows and columns in each array. So that's step 1. Match to complete the array. That's step 2. Then fill out the blanks to make true equations to find the array's area. Okay, so step 1 is to complete these arrays. Now, we could do that. Look, I'm going to finish that line, finish that line. You just have to be kind of precise here. Take your time. Then I can go down to this one, down with that one, and down with that one. So that's filled in now. And I did all that. I filled in this bottom right-hand portion. And that's fine, but already existing, I had 1, 2, 3, 4, 5. I had a 5 by 1, 2, 3, 4, 5, 6. So I had a 5 centimeter by 6 centimeter array. I filled it in, but I could have determined the side lengths anyway by looking at this top row and this left row in this case. So I have that. Now I'm going to try to match that to one down here. I see 1, 2, 3, 4. Well, that doesn't work. 1, 2, 3, 4, 5. Well, that's right, but 3 doesn't work. You might not be able to. There we go. You could probably see it all the way down here. We have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So those two match right there. So I'm going to do that. And then next to, I'm going to say 5 centimeters times 6 centimeters. And to find that area, understanding level 1 would be that you sort of count all the squares in there. Hopefully we're moving beyond that. Level 2 would be you count by 5, so like 5, 10, 15, 20, 25, 30. You could get group count that way. Or, level 3 is that we understand we can multiply 2 side lengths to find area. 5 times 6 centimeters each is 30 square centimeters. All right, let's move on to the second one. Now in this one, you notice I can't do the multiplication right away. I do have to fill it in because at least a portion of it, because I don't yet know the length and the height, or the width and the height. So I'm going to start with this one, and right away I now see, 3 centimeters is my height, and I could do that over here too, and I could figure it out pretty quickly. That you see I have 1, 2, 3. And now the bottom, since I filled that in, I have 1, 2, 3, 4, 5, 6, 7. I have enough information at this point to move on. So, I'm not going to be too tough on you in class, like in terms of filling out the rest of this. If you can identify this row and that row, or those side links, and then do the multiplication, I'm not really concerned if you spend time filling in the rest of these squares if you're at a level of understanding where you can do that and know what the area is going to be. If you still need to group count or count individually, then yeah, by all means, go ahead and fill this in and get a better idea for yourself of what it means to have 3 rows of 7. But if you're a kid that can see that you have that row there and this row here and that you're going to multiply them, then you don't need to fill out the rest. Once you get the measurements you need, you can go ahead and move on. Let's see, I have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3. Oh, you can't see the one on the bottom there. Of course, our first two are the ones that match with the bottom two. 1, 2, 3, 4, 5, 6, 7, 8, 9. I don't need to count that. 1, 2, 3, 4, 5, 6, 7. 7 and 3. So 3 and 7. Well, those two match. And so I have 3 centimeters times 7 centimeters. 3 times 7 is 21. So that's 21 square centimeters. All right, let's just pick one more. Okay, let's go all the way down here and do this sort of funky looking one, letter D. All right, so what do I need to know about D? Well, I need to know two side lengths, not opposite side lengths, but adjacent, meaning they're next to each other. It does me no good to just know the top and the bottom or just the left and the right. But in this case, I'm going to fill out, I'm going to finish the top. So look, just by putting that line in there, I can see I have 1, 2, 3, 4, 5 centimeters. All right, see, so I've figured out that part already. Now I need to figure out either the right side or the left side. I think it's easiest to do the right side in this case because I could put a line in there and a line down here. And now I say I have 1, 2, 3, 4 centimeters. Now again, I could go in and fill in the rest of this if I needed to. I could do this and that. I could fill those in, but I don't need to. If we've developed a level of understanding where we see that we can take two adjacent side lengths, two side lengths that are next to each other, and multiply them, it's not really necessary to fill in all of these blanks. You just have to do enough to figure out what the lengths of the sides are. And once you figured out that they're 5 and 4, you can match that. Of course, it's, let's see, it's with this one right here. 2, 3, 4. Oh, no, it's not. I take that back. Why can't I seem to find this one, guys? 4. 5 times 4. I think that we have one that doesn't line up to any of our partners over here. We do, huh, interesting. Okay, well, anyway, this is 5 centimeters times 4 centimeters equals 20 square centimeters. Mr. Brunel's kind of confused about why this didn't line up. I'm thinking that they meant for, see how this one up here? I think when they made this paper, they meant for this to be a 5 times 4 because we have 4 here. But then we have 1, 2, 3, 4, 5, 6. I think they gave us an extra row. So those don't line up. We should probably talk to the people here at Eureka Math about that. All right, let's take a look at the backside because we have some more, we got to apply our knowledge. We know what we're doing now. Now we need to learn how we can use that information. Camera's almost tipping over here. So Sheena, and again, remember when we're doing word problems, if you get to a name that you don't know how to pronounce, that's okay. Just call them by their first letter. So we could call this S. S skip counts by 6s to find the total square units in the rectangle below. She says there are 42 square units. Is she right? Explain your answer. Okay, well, 1, 2, 3, 4, 5, 6. She can definitely count by 6s, right? So we know that this side length is 6 units. All right, she's correct. But do we know how many units are here yet, or even better, down here? Well, not yet. No, we don't. But we can figure that out if we complete this rectangle. Look, just by drawing that line in there, I can now figure out how many, the side length of this bottom part of the rectangle. 1, 2, 3, 4, 5, 6, 7, 8. 8 centimeters. All right, so what's my formula or my number sentence for finding area? Well, it's 6 units. Oops, sorry, this isn't centimeters. It's units. I always tell you guys to be careful with units, so I got to do the same. 6 units times 8 units. And we know 6 times 8 is 48 square units. So I would say she's incorrect because the side lengths are 6 and 8, and 6 times 8 is 48 square units in this case, where she said 42. So she had to be a little bit more careful when she when she filled this in. One thing I do want to point out here, because I've noticed it coming up recently, is that we need to be careful with side lengths are just measured in units. They're one-dimensional, right? Where it's just a length, like you measure with a ruler. The only thing that's going to get square units is when we're measuring the inside or the space taken up by something. So when we measure any side length, it's just in regular old units. And then when we measure, when we multiply those together to get area, we measure in square units. All right, we have an interesting problem here. One that, later in the unit, we're going to even expand on a problem like this to make it more complicated. But this one basically says the tile floor in Brandon's living room has a rug on it as shown below. So here's the tile, the tile floor is the grid. The rug is covering part of it. How many square tiles are in the floor, including the tiles under the rug? So that's saying, including all of this, including everything covered by the rug, because there are tiles under there. Just because they're covered with a carpet doesn't mean they're not there. Including that, how many tiles are on this floor? Well, the first and easiest thing to do is figure out this side length right here, because we can just count that. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 doesn't give us a unit, so we'll just call it units. It doesn't say feet or inches or anything like that. I assume it's feet. And then we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 units. Now this was a little bit easier because we could see peeking through there the tops of those tiles, so we can just count. And then we say 9 units times 10 units equals 90 square units. So this is like the same sort of problem as one where they're like up here where there are blanks. The difference is rather than leaving blanks, they just covered it with an object, right? And either way, the purpose of this is that you can't see a portion of the grid. All right, let's do one more, and then we'll be done for today's lesson. Our camera really doesn't want to cooperate today. There we go. Abdul is creating a stained glass window with square inch glass tiles. So square inch, I'm going to underline that. That tells me my unit. How many more square inch glass tiles does Abdul need to finish his glass window? Explain your answer. So basically, he needs to cover this area, right? And so far he's done these tiles right here, right? We need to figure out how many more he needs to go. So 1, 2, 3, 4, 5, 6, 7. I'm going to find, so that's 7 inches. I'm going to find the area of the whole thing first, and I'm going to subtract what he's already done to find out the missing piece. 1, 2, 3, 4, 5, 6 inches. So total area equals 7 inches times 6 inches. 7 times 6 is 42 square inches. So this whole thing is going to take up 42 square inches. Now he's already put down some tiles. So I need to say tiles already there. Well, he has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 tiles. Or 12 square inches, because each one's a square inch. A-R-E. There we go. Now, when you, never mind, we'll talk about that part in class. That's going to get too complicated for the video. So I have 42 total. I've already used 12, so I'm finding difference. So 42 minus 12 is 30 square inch tiles is how many more he needs. And the way I can double check that, I could say, if I take the amount he still has to do and I add it to the amount he's already done, I should end up with the total area. Make sure that total space is covered. And yes, 30 plus 12 is 42. All right, so today was just a continuation of the work we've been doing with area. It was a chance for us to take a look at a slightly more complicated set of problems in which we're missing pieces of that array or that grid that we've been working with. But I know you guys have developed a good sort of conceptual understanding of the fact that you can multiply two side lengths defined area. So I'm hoping that this sort of work that we did today is making a lot of sense to you. All right, guys, ask questions you have, please.